Laundry appliances often include both a washer and a dryer, yet their usage patterns differ significantly. One might wash clothes and hang them to dry, or dry clothes previously washed. Separately installed washers and dryers are also common. To account for these variations, it's crucial to consider all laundry methods when calculating electrical load in a residence. The National Electrical Code mandates separate load calculations for dryers due to their substantial energy consumption. Dryers typically demand more power than washers and generate considerable heat, potentially overloading the electrical system. Independent calculation ensures the system can handle the dryer's load without compromising safety or performance. To accurately calculate the dryer load, you need two key pieces of information. Firstly, the dryer's wattage, and secondly, its estimated daily usage in hours. The dryer's wattage is usually found on the appliance's nameplate, a label affixed to the dryer itself. The daily usage varies based on household size and laundry volume. Larger households naturally generate more laundry, leading to more frequent dryer use. Once you've determined the dryer load, add it to the washer load to obtain the total laundry room load. This total load figure is then used to determine the appropriate size of the electrical service for the entire building. This ensures that the electrical system can safely and reliably power all appliances, including the laundry equipment. The NEC provides specific guidelines and tables for calculating these loads. These resources are essential for electrical contractors and anyone involved in residential electrical design. These tables offer factors and formulas that account for the intermittent nature of appliance usage and the diversity of loads within a dwelling. By adhering to the NEC requirements for separate dryer load calculations, electrical systems are designed to safely handle the demands of modern households. This helps prevent overloads, voltage drops, and potential electrical hazards. When performing load calculations for residential buildings, it's very important to consult the latest edition of the NEC and any applicable local amendments. The NEC is updated regularly to reflect changes in technology and best practices. Local amendments may also exist to address specific conditions or requirements within a particular jurisdiction. By staying up to date on the latest codes and regulations, you can ensure that electrical installations are safe, compliant, and efficient. It is also very important to consider the voltage and amperage ratings of the electrical system components, such as circuit breakers, conductors, and receptacles. These components must be properly sized to handle the calculated loads. Using undersized components can lead to overheating, insulation damage, and even fires. In addition to the NEC requirements, it is also good practice to consider future load growth when designing an electrical system. As households acquire more appliances and electronic devices, their electrical demand tends to increase over time. By providing some extra capacity in the electrical system, you can avoid the need for costly upgrades in the future. The NEC provides guidelines for calculating the minimum size of the electrical service for a dwelling unit. However, it is often advisable to install a larger service than the minimum required, especially in new construction. This will provide greater flexibility and allow for future expansion of the electrical system. When calculating the load for dryers, it is important to use the correct voltage rating. In most residential buildings, dryers are supplied with 240 volts power. However, some older dryers may be designed to operate on 120 volts. Using the wrong voltage can damage the dryer or create a fire hazard. It is also important to use the correct size of conductors for the dryer circuit. The conductors must be large enough to carry the maximum current the dryer will draw. Using undersized conductors can cause the conductors to overheat and create a fire hazard. The NEC specifies the minimum size of conductors that are required for different circuit ratings. When installing a dryer circuit, it is important to use a dedicated circuit breaker. This means that the dryer circuit should not share a circuit breaker with any other appliances or devices. Using a dedicated circuit breaker will help to prevent overloads and ensure that the dryer receives the proper amount of power. It is also important to use a ground fault circuit interrupter, or GFCI receptacle for the dryer circuit. A GFCI receptacle is designed to protect against electrical shock. If a ground fault occurs, the GFCI receptacle will trip and cut off the power to the dryer. This can help to prevent serious injury or death. In addition to the electrical requirements, there are also some mechanical requirements that must be followed when installing a dryer. The dryer must be properly vented to the outside to remove moisture and lint. The vent duct must be made of non-combustible material and must be properly sized to prevent restrictions. Restrictions in the vent duct can cause the dryer to overheat and create a fire hazard. The dryer must also be installed on a level surface and must be properly secured to prevent it from tipping over. Tipping over can damage the dryer and create a safety hazard. When installing a dryer, it is important to follow all of the manufacturer's instructions. The manufacturer's instructions will provide specific information about the installation and operation of the dryer. Following the manufacturer's instructions will help to ensure that the dryer is installed safely and properly. In summary, calculating the electrical load for dryers separately from washers is a requirement of the NEC. This is because dryers use a significant amount of energy and can put a strain on the electrical system. To calculate the load for dryers, you need to know the wattage of the dryer and the number of hours that it will be used per day. Once you have calculated the load for dryers, you can add it to the load for washers to get the total load for the laundry room. This total load will then be used to determine the size of the electrical service that is required for the building. By following the NEC requirements and best practices for dryer installation, you can help to ensure that the electrical system is safe, compliant, and efficient. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is important to consult the NEC whenever you are working on electrical projects. The NEC is updated every 3 years, so it is important to use the latest edition. The NEC is available from the National Fire Protection Association, or NFPA. In addition to the NEC, there are also a number of other resources that can be helpful when working on electrical projects. These resources include electrical textbooks, online tutorials, and training courses. By taking advantage of these resources, you can improve your knowledge and skills and ensure that you are working safely and effectively. Always remember to disconnect power when working on electrical systems, and seek a qualified electrician if you are unsure about any procedures. When sizing conductors for dryer circuit, refer to NEC Table 310.15b16 to determine the ampacity of the conductors based on their size and insulation type. Ensure that the selected conductor size has an ampacity equal to or greater than the overcurrent protection device. For example, a 30 amp circuit requires conductors with an ampacity of at least 30 amps. The overcurrent protection device, typically a circuit breaker, protects the circuit from overloads and short circuits. Select a circuit breaker with an amperage rating that is appropriate for the dryer's wattage and voltage. Refer to NEC Section 240.4d for requirements regarding conductor protection. Be sure to properly ground the dryer to protect against electrical shock. The grounding conductor should be connected to the grounding electrode system of the building. Refer to NEC Article 250 for grounding requirements. Proper grounding provides a low impedance path for fault current, which helps to trip the circuit breaker quickly and safely. When running the dryer vent, use rigid metal ductwork whenever possible. Rigid metal ductwork is less likely to become clogged with lint and is more fire resistant than flexible ductwork. If flexible ductwork is used, it should be as short and straight as possible. Clean the dryer vent regularly to remove lint buildup. Lint buildup can reduce the efficiency of the dryer and create a fire hazard. The dryer vent should be cleaned at least once a year, or more often if the dryer is used frequently. Inspect the dryer regularly for any signs of damage or wear. Pay close attention to the power cord, vent duct, and lint filter. Replace any damaged or worn parts immediately. A well-maintained dryer will operate more efficiently and safely. Consider the type of laundry appliances being installed. Some high-efficiency washers and dryers have lower energy consumption than traditional models. Using energy-efficient appliances can reduce the overall electrical load in the building. The NEC provides guidelines for calculating the demand load for various types of appliances. Understanding these guidelines can help you to size the electrical service appropriately. Also be sure to take into account any other electrical loads that will be served by the same electrical panel. These loads may include lighting, receptacles, and other appliances. The total load in the panel should not exceed its rating. If the total load exceeds the panel rating, the panel will need to be upgraded. Upgrading an electrical panel can be a costly and time-consuming process, so it is important to size the panel correctly from the beginning. When calculating the load for a multi-family dwelling, the NEC allows for demand factors to be applied to the total load. Demand factors take into account the fact that not all appliances will be used at the same time. Applying demand factors can reduce the size of the electrical service that is required. Demand factors are based on the number of dwelling units in the building. For example, a larger building will have a lower demand factor than a smaller building.